The operational efficiency model is a little different. So if you look at the plant engineers trying to keep the project running, the primary metric is product throughput. How much throughput can I get through? How much can I match my production demands? This was easy when we were all in sold-out environments. As you get less and less sold out, it looks a little different, but that's okay. You guys can take a joke. And so you're trying to maximize project throughput while you're trying to minimize your costs. The two costs that we've traditionally trying to minimize is consumed energy and consumed material. Okay, so there's an efficiency model. That's the efficiency model. The problem with this model has been that this works as long as the value of the products you're pushing through the plant and the energy price and the material price are relatively constant. If they're relatively constant, this multi-objective optimization problem works. If the value of the electricity that you're using in your plant varies reasonably frequently, the price you're paying for electricity, that means that this vector, all of a sudden, if we, instead of just consumed energy, this vector doesn't tell the story on profitability. We can reduce the amount of energy consumed without reducing the price we're paying. As a matter of fact, increasing the price we're paying because we're consuming the energy at the high price periods during the day. So all of a sudden, we have an interesting dilemma. That is, your plants can be running very efficiently by this model and still not be profitable. 15 years ago, that wasn't the case. 15 years ago, this was a given. If you could run it efficiently, it directly translated to profitability. Today, efficiency doesn't directly translate to profitability. This is a dilemma, which fortunately for us, we can say, that's the executive's problem, that's not ours. That's the business team's problem, that's not ours. I got to tell you, we can't walk away from it that easy. We can't walk away from it. Why? Because it's a real-time control problem. How many of your IT departments have expertise in real-time control? You dump it on the IT department, you're not going to solve the problem. You work with the IT department to apply real-time control to the business problem, we can solve these things. The interesting thing about this model, this is the efficiency model, is this is a 3-objective optimization problem. My first PhD was in industrial engineering, and what we studied was optimization. We've become very good at one-objective optimization problems. We're not very good if you have multiple objective optimization problems. So mathematically, we have a real hard time solving this problem. The mathematics just isn't there and isn't fast enough to solve this. So what do? We take an operator with a high school education, stick him in front of a console, and say, operate the plant efficiently. By the way, the interesting thing about that is, our experience is, if they can see what efficiency is, if we make it visible, an operator with 5 years experience, high school education, will optimize this problem within 2 months. And they'll learn how to do it. The fascinating thing about what we do, we all work in feedback control. We're feedback control experts. Do you realize that the primary learning technique of the human brain is feedback control? Trial and error? What's trial and error? It's feedback control. We are creating training systems in our automation systems where if we show the operators what it is to be efficient, they will learn because it's a learning system. By the way, they learn anyway. What are they learning today? They're learning how to set the plant as far away from alarm limits as they can because they don't want to get alarms. Right? That's what they do. The primary instrument of operation in every control room I've been in is the newspaper. Why? Because we train the operators, if there's no alarm, read the sports page. Right? And if you get an alarm, finish the article you're reading, and then go take care of the alarm. And then come back and read the next article. Has anybody been in a control room without a newspaper in it? I've never seen one. It's stunning to me. But that's us. We're the problem, by the way. Engineers, we're the problem. We train operators how not to think. And yet, what we've learned over the years in learning theory is experiential learning is 10 times more powerful than academic learning. We all like putting letters behind our names and all that kind of stuff. It's not nearly as good as experiential training. What are we doing with operators? We're sitting them in front of an experiential training system day after day after day after day, and they're learning that plant from a point of view nobody else has ever learned the plant before. How come we aren't taking advantage of it? We should be taking advantage of that. We have to understand the impact we're having at every point in these operations.